Hello, this is Mr. Wynn with lesson 10-2, arithmetic sequences and series. So remember in 10-1 we used the point sub form to find the specific term of the arithmetic sequence because the graph was linear. It is possible to find the explicit equation to find any term in the arithmetic sequence by using the same process. We just use general letters, so instead of x, y, x1, y1, we use a sub 1, a sub 2, a sub 3, and so on. And the common difference is d, which leaves us d. So they solved it, and they got this equation right here. Here is the main form we're always going to use. That'll just find any term. Could find the 100th term, the 1000th term. That take way too long to just add the thing over and over again 1,000 times. There is an equivalent formula, which is this, where instead of a sub 1, we have a sub b. And you only use that when they don't give you the first term. For example, they give you the 7th term and the 20th term, right? So we have to use that, which is 13 spaces away. But for the most part, we will be using this formula. Alright, so the first problem, find the nth term. Find the 12th term of this sequence. So we see it's 9, 16, 20, 30. That's 4 of the terms. We need 8 more. And you could find the difference and add it over and over again. Let's write the formula first, though. It was a sub n equals a sub 1 plus n minus 1 times d. Alright, so right here, we have to find a sub 1, n, and d. Well, thankfully we know a sub 1 is the first number, which is 9. To find d, the common difference, we have to subtract. So it'll be the 16 minus 9, that's 7, which is our d, so d equals 7. And you could do 9 plus 7, 16, 6 plus 7 is 23, 23 plus 7 is 30, 30 plus 7 is 37, 37 plus 7 is 44, and so on, but that takes way too long to count. So we'll just fill in the formula. So we're trying to find the 12th term. A sub 12 equals a sub 1 is 9 plus n, which is 12 minus 1 times d, which is 7. We're going to simplify. So it's 9 plus 12 minus 1 is 11 times 7. Well, 11 times 7 is 77 plus 9 gives us 86. So that is our 12th term. Alright, the reason why we're doing times 11 is because the first term counts itself. So we have to add 7 to the first term 11 times. So the second term is add 7 once. The third term gets to add 7 twice. Right, to the fourth term, 30, you get to add 7 3 times. 9 plus 7 plus 7 plus 7 is 30. Alright, you can even find the explicit or direct equation, which is pretty much what we just did. So write the equation for the nth term. So same thing. I'm going to write the formula. A sub n equals a sub 1 plus n minus 1 times d. We don't know a sub n, but we need to find d and a sub 1. So we know a sub 1 is 5, so that's easy. D, the common difference would be negative 13 minus 5 gives us negative 18. That's our d. So it looks like we're subtracting 18 over and over. 5 minus 18 is negative 13. Negative 13 minus 18 is negative 31. Negative 13 minus 18 makes negative 49, and so on. So our final formula is a sub n will be our first term 5 plus n, we don't know, minus 1 times our difference is negative 18 up in parentheses. And that's it. We use this formula to find, say, the 100th term. We just plug in 100 for n, and you'll get whatever the 100th number would be in the sequence. Now actually, let's clean this up. Let's actually simplify it. Let's distribute. So that's 5 minus 18n plus 18, which then turns into negative 18n plus 23. That is our final formula. Alright, so we plug in, say you plug in 1 to the first term is, right? Negative 18 times 1 is negative 18 plus 23 is 5. First term gone. If I plug in 2, negative 18 times 2 is negative 36. Negative 36 plus 23 is negative 13. There you go. So we've got our second term. Alright, so use the one in red, not the one in blue. Alright, same thing. Let's try this. Here, we're going to find the same formula, same equation. A sub n is a sub 1 plus n minus 1 times d. But they don't give us a sub 1. Now we could look for it. Or we can use a shortcut, is the alternate equivalent formula. the one down here where I use a sub b, and basically I change a1 to a b and change the 1 to b. So let's do that, make our life easier. We're going to use this other formula. A sub 1 is a sub 5 plus n minus 5 times d. So they gave us a sub 5. All I do is find d, or they give us d as well. So I plug these two in and simplify. So a sub 5 is 19 plus, we don't know n, minus 5 times d is 6. Let's distribute. So that's 19 plus 6n minus 30. And we can combine that, and I'll go over here to the left. Our final equation is a sub n equals 6n minus 11. And we can check pretty simply. If they want the fifth term, we know it's 19, right? So 6 times 5 is 30. 30 minus 11 is 19. Done. If I want to find the hundredth term, I'd plug in 100 for n, which would make it 600 minus 11, 589. Alright, now sometimes you're given two terms in sequence, but they're not consecutive, meaning they're not back to back in a row. The terms in between them are called the arithmetic means. Alright, and we can find those in the middle. So here's example 3. Find the arithmetic means in the sequence -8, question mark, all to 22. We need 4 of them in the middle. So that's why they wrote 4 question marks. So we're still going to use the formula, and actually we'll call this a sub 1, and a sub we'll call this a sub 6. Right, because it's 4 in there, because a2, a3, a4, and a sub 5 are all missing. So our formula, a sub n, here's the normal formula first off, plus n minus 1 times d, but we're going to use it with 6 because we don't know what the rest are. So a sub 6 would be a sub 1 plus 6 minus 1 times d, and we're going to solve this for d. We're going to plug in what we know. So a sub 6 we know is 22 equals a sub 1 is -8 plus 6 minus 1 is 5 times d is 5d. We're going to subtract, no, we're going to add 8. So that makes this 30 equals 5d. We're going to divide by 5. We get d equals 6. Now that we know the difference, common difference, we're going to use it. We're going to add it. So -8 plus 6 makes this 14. Now use blue. Alright, then 14 plus 6 will make this 20. Alright, 20 plus 6 will make this 26. Oh, I'm bad at math. Alright, so -8 plus 6 makes -2. -2 plus 6 makes +4. +4 plus 6 makes +10. +10 plus 6 makes 16. And just make sure it's good, 16 plus 6 makes 22. So those are my 4 numbers. -2, 4, 10, and 16 are the arithmetic means between -8 and 22. And I knew I messed up because I was about to go over that 22. I'm like, oh, I missed the negative numbers. Alright, we also have a series. A series is formed when the terms of a sequence are added. And an arithmetic series is indicated sum of the terms of a sequence, and the sum of the first n terms is called the partial sum, and here are the formulas. Sometimes we have to know a1, an, or n must be before we can find the sum, but here's the formula, and there's a very good story with this. I'll probably tell you on in class. But the sum will be number of terms times the first term plus the last term all over 2. Alright, the sum of the series is that. Alright, so use the sum formulas. So find the sum of 12 plus 19 plus 26 plus blah 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 plus all the way to 180. So first off, we figure out how many terms are there to go from 12 all the way to 180, and we can use that formula from before. Remember, a sub n equals a sub 1 plus n minus 1 times d. Well, we gotta know what d is, so let's find the common difference real fast. 19 minus 12 is 7, so we're adding 7. So I plug that in. Our last term, a sub n, is 180 equals 12 plus, we don't know n, minus 1 times 7. I'm going to distribute. This is green. Actually, I'll even subtract 12 as well. So 168 equals 7n minus 7. I'm going to add 7. 175 equals 7n. Then I'm going to divide. So I'm going to divide by 7. I get 25. We know there are 25 terms. So now I can use that sum formula. The sum formula was this. The sum of the series will be n times a1 plus a2n all over 2. Alright, so I'm going to plug in. So there are 25 terms times the first term was 12 plus the last term is 180 all over 2. And you can use that in the calculator, and we get 2,400. Again, it's a really nice story that goes with this, but I'll tell you that in class later. Alright, next slide. Alright, you can use some formula to find the terms of a series. We can go backwards actually. So find the first 3 terms of the series where it has the first term is 7, the last term is 79, and the sum of all the numbers is 430. So that formula, S sub n will be n times a1 plus a n over 2. We fill in our numbers. S sub n is 430. N we don't know. A1 is 7 plus 79 over 2. Alright, a lot of things we could do here, but let's work on this other fraction. 430 equals, that's going to be 86. 86 divided by 2 is 43. So 43 times n. Divide by 43, you get n is 10. There are 10 terms. Once you know n, you got to find d. So now we're going to the other formula. Remember, a sub n equals a1 plus n minus 1 times d. Well, we know a sub n is 79. A sub 1 is 7. Plus, we know there's 10 terms, so 10 minus 1 times d, which is missing. I'm subtract 7, that makes us 72, equals 10 minus 1 is 9d. Divide by 9, we get d equals 8. Lastly, once we have d, a common difference is added to the original term. So the first term was 7, I add 8 to make 15, I add it again to make 23. Those are my first 3 terms. Alright, so find n, find d, then use it with our first term, a sub 1. Alright, last example, a series can be written in shorthand by using singular notation. It looks like this sign. It has the first value to plug in on the bottom, the last value to plug in on top, and the function or equation to plug into on the side. Alright, so here k, the first value is 1, plug it in into our fk, whatever that is, and then find last in. So here's an example, you can look at it. But we're going to start using our example 6, so find the sum of that. So first value is 4. I'm plugging 4 into k. So 6 times 4 minus 1, 24 minus 1, that's 23. That is our first term. That's a sub 1. So a sub 1 is 23. Now I'm going to find our last term, a sub n, which is 18. Plug in 18 for k. 6 times 18 minus 1, that is 108 minus 1, that makes 107. Next we need n, the number of terms there are. So we know a sub n is 107. Alright, so let's think about it fast. If the first term plug was 4, say k was 4 and on top was 5. If I do 5 minus 4, that's 1. That's not one term, it's 2 terms. I'd plug in 4 and 5. So what you do is you subtract the top from the bottom, or top minus bottom, and you add 1. So n is going to be the top number 18 minus 4 plus 1, which turns into 14 plus 1, 15 terms. Alright, now that we have a1, an, and n, we can now plug into the other formula, the sum formula, which I try to do up here. So the sum is n times a1 plus an all over 2. If I fill in the numbers, let me move this out of the way. I can't move that, that's fine. It's going to be, the sum will be 15 times a1 is 23 plus 107 all over 2. You plug that into a calculator and see what the answer is, which we get 975. That is the sum. Alright, I'll leave out the practice problem. Find the 25th term of that series, and there's your answer. Thanks for watching. See you in class. Bye.